One of the most often things you're going to do in the trades is to read a tool of measure. By tools of measure, we mean meters, gauges, and any other thing that you take a measurement with. Tools of measurements are available for all kinds of measurable quantities. For example, length, distance, volume, speed. The scale of each tool of measure determines the accuracy of the measurement. In other words, the larger the scale, the less accurate the measurement. The smaller the scale, the more accurate the measurement. Start with the U.S. conventional rules. In other words, in linear measurements, or length, the space between the whole number can be divided as many parts as possible. These fractional parts are a division of that whole number. The denominator of the fraction gives the number of parts the whole number was divided into. An example of this is the ruler. Okay, between the red and the red line is 1 inch. The half scale, or the 1/2, where the blue line is the first division of 2, or half. 2 is the number of divisions. On this ruler, the inch is divided into 16 equal pieces. Thus, each line is 1/16 of an inch. The distance between these two lines is 1 inch, 14/16, or 1 inch, 7/8. Each line size is a separate scale. The top arrow is on the 1/8 scale. The bottom arrow is on the inches. The other rule is the metric system. The standard metric system uses power of 10 for all measurements. For example, 1 meter is 10 decimeters, or 100 centimeters, or 1,000 millimeters. 1 decimeter equals 10 centimeters, or 100 millimeters. 10 millimeters equals 1 centimeter, or 0.1 decimeters. See, by moving from one scale to another in the metric system, you're just moving the decimal place. The conversion between these scales is limited to moving the decimal place to the left or right by a certain number of places. Measurements on a ruler are marked first in the meter marks. They're also marked in each centimeter. Each 10 millimeters are marked up to the meter. The thing to remember is 1 meter is 1,000 millimeters. The distance between the two arrows is 2 centimeters, which is 20 millimeters, 0.2 decimeters, or 0.02 meters. The triangulated drafting scale is used by architects, engineers, designers, and drafters. These scales can be reduced or enlarged so that drawing can be made that fits on a paper. Each of these scales have a ratio. 1:1 means that the drawing has not been reduced or enlarged. 1:6 means that every measurement must be multiplied by 6 to get the actual measurement. The triangulated drafting scale is just a triangle scale that each side of it has a different scale on it. Whatever side you use, make sure you start with the 0. So you might be measuring from left to right or from right to left. Each scale is marked on the scale. Micrometers are also another tool of measurement. They're used to measure the thickness or outside diameter of an object, such as wire, pipes, or the thickness of a piece of sheet metal. You'll notice there are a number of parts on the micrometer. You have a thimble that slips over the barrel. You have a lock nut. You have a spindle and an anvil as long as the frame. Place the object to be measured into the micrometer and adjust the spindle so that it is touching. Read the measurement from the barrel. In this example, you're first going to read how many numbers are to the left of the thimble. This is signified by the blue. Write that number down. Next, read how many visible 0.025 inch lines are on the sleeve. So in this case, there's 3 lines visible. So multiply 0.025 times 3. That's 0.075. Next, on the thimble, for the thousandths, read the 0.007, or the 7 line is what's matching up, and write this down. Add all the numbers together. 0.5 plus 0.075 plus 0.007 is 0.583 inches. That's the thickness of the diameter of the object. The Vernier Calipers are another tool of measurement. They differ from the micrometer. that you can read both the inside and the outside of an object. To use the calipers, slide the movable jaws so that they almost touch the object being measured, and then use the adjusting nut to move the jaws into contact with the object. Do not over tighten. Okay, the jaws, there's two sets of jaws in this diagram. The jaws at number 1 measure the outside of the object. The jaws at number 2 measure the inside of the object. Then you have your main scale, signified by 4 and 5, and then you have your vernier scale, signified by 6 and 7. There's also a retainer. Determine the number of inches, 1/10 of an inch, and 1/40 of an inch between the 0 line on the beam and the 0 line on the vernier plate. Add these numbers together. Then you count the number of graduations that lie between the 0 line on the plate and the line on the plate that coincides with a line on the scale. Each of these is equal to 0.001 inch. Multiply the number of graduations by 0.001 and add the two numbers together to get the measurement. This is another look of the vernier caliper. Again, you'll have to use all the numbers, either inches or centimeters, in order to get your measurement. Another tool you're going to use quite often is the meter. Now, analog meters have almost gone away at this point. You don't see them that often unless you're taking very scientific measurements. Most often in the trades we're using digital meters as they stand up better, and they are just more applicable to what we're doing, which is quick measurements. Looking at this picture of the meter, you'll notice that there's a scale up top, and there's a needle. Right now it's on the left of the scale. You'll notice that there's a number of different choices. You have ohms, DC, AC, and then temperature. Okay, DC. So you rotate the little dial at the bottom to the appropriate scale. Take your measurements, and then you want to make sure you read off the scale up top that matches your dial settings.